Recording in progress.
Yes, thank you for joining us this evening. You were brought into the session with microphone and video off, and if you have questions, please put them in the chat. Megan will collect them and address them to Gary after his presentation. We are recording the program, and it will be made available on the Detroit Public Library YouTube channel and through Wayne State University's website. My name is Jennifer Dye. I'm a librarian at Detroit Public Library. We've been working with several of the local astronomy groups in the last few years, and very fortunately, about 2 years ago, we started working with Megan McCullen, director of the Wayne State University Planetarium. She helps me mightily on the Zoom programs, and she's provided us with a link to the community of Wayne State University faculty and alumni. Megan, would you like to say a few words about the planetarium and your programs?
Sure. Thanks everyone for being here. We're always glad to participate in these programs. And we currently have programs, free shows on Friday nights at the Wayne State University Planetarium that are in person. I will post a link to those in the chat as soon as I'm done talking at you. We're working on developing some in-person programming for the fall. We've got our Science Under the Dome lecture series coming back, and we're starting with an astronomy faculty member who joined us last year as our second full-time astronomy faculty member. She also actually went to school here. Dr. Renee Ludlam did her undergraduate with us and is now a professor here. So she will be talking about her research and just news from the planetarium and from Wayne State. We're actually bringing on a third astronomer this fall as well. So our astronomy program has grown a lot in the last 7 years, from nobody to 1 to 3 in terms of full-time faculty. So we're really excited about that. And that should mean more great programming. They're all on my advisory board for the planetarium. So hopefully you'll see some of their faces giving talks here in the next year as well.
Thank you, Megan. Our speaker tonight, Gary G.M. Ross, is active in various astronomy communities. I first met him through the Warren Astronomical Society, and he's been very helpful in the effort to spread the wonder of astronomy to the DPL community. As you will see this evening, he has some strong opinions. And Clayton Carey is providing technical support and the PowerPoint using images from Zoom, or I'm from NASA, not from Zoom. Gary, would you like to go ahead now?
Thank you. Pleased and in no small part honored. God of our fathers, whose almighty hand brings forth in beauty all the starry band of shining worlds in splendor through the sky. We sang that song in junior high choir. I was already involved in astronomy, and there was something deeply moving about that old hymn, about shining worlds in splendor through the sky. And there are many, many now shining worlds, starting with 51 Pegasi in 1992, I believe. But we will be dealing tonight or this evening with something and bodies, shining worlds much closer to home. And for a head note, in order to get the audience's undivided attention, Clayton and I are calling enough from Martian exploration by the United States. Let's make that very plain. There is nothing wrong with the exploration of Mars. It is to be encouraged. We find it necessary to point out, for those of the audience who are too young to remember or didn't know what was going on in the first place, that the Soviet Union used to be very active in planetary exploration, particularly with Mars. They sent 5 probes to Mars starting in 1960, all of which failed before we got our first mariner there in 1965, I believe. The Soviets are to be commended for their energy, their commitment, although their equipment was not up to the task, which was considerable in the 1960s. I pointed out in a similar lecture that the Sovs were just too dumb to know when they were whipped, which is probably why they prevailed on the Eastern Front. The United States has done spectacularly well in the exploration of Mars, not only with the first Mariner, which was the first successful probe to Mars, but I think particularly, and this brings back pleasant memories of what I call Viking Summer in 1976, when the NASA planted very close to one another 2 Viking landers a hemisphere apart on Mars, and they both worked flawlessly. To my mind, that was, minus the manned expeditions into space, the most spectacular astronomy experiment of planetary work that had been performed to that date. There, of course, have been other orbiters and rovers dispatched by the United States, most of them successful or spectacularly so. But it is our view that we should leave Mars to other countries and other consortia of countries. These other countries are capable of doing the work themselves and are to date heavily engaged in such an enterprise on Mars. And it is time for us to leave it to them, because there is much unfinished or enticing work waiting in the solar system. Fascinating, and in some cases, quite moving. What is out there in our solar system is a multiplicity of planets, of, to use the famous phrase, strange new worlds, and to show the variety of what awaits us. And we do not imply that the United States and other nations have been significantly deficient in the work on other planets besides Mars. But we point out that there is such a multiplicity of discoveries to be made. Io, or if one prefers Io, the fascinating moon of Jupiter, a world that is one big ice cap. And we ask the question, what could be frozen, locked in that ice? We need landers on Io with microscopes, because if there are organisms locked in that ice or been forced to the surface from what is very likely a subsurface ocean, maybe a panthalassa under the ice caps, we want to see what they look like and if they're reproducing, or even if they're not reproducing. We would like to see if there could be life on that ocean under the ice caps of Io. It is necessary to calculate any drag that the ice cap, the global ice cap or the ice sheet must be exerting on a subsurface ocean, because even though Io is tidally locked with one face toward Jupiter, the mother planet, there is nonetheless drag or friction between whatever water surface there is under the ice, and must investigate the rate of stretching and collapsing and fissuring of the world ice cap, because the evidence to date, going back to the 1970s, is that the surface of Io is very active and has been active for, well, we could say since inception. We have no way of knowing of the rate of the fissuring and collapsing and the pressure ridges that are forming. And it would be important to put landers, more than one, so they can communicate with an orbiting probe to tell us the rate or even the existence of collapse and pressure ridge formation. So this is the second moon of Jupiter. In other words, it is close to the mother planet. What is the contribution of the powerful gravity of Jupiter on the surface of Io? For all of this, we have to establish stations, and more than one or two on that world, to pick up the traces or even the gross effect of Jupiter's gravitation. Callisto, the blue moon. It is amazing how different all the moons look from one another. There are the 4 Galilean moons, but Callisto is the blue moon, and in a small telescope, an amateur's telescope, it is markedly the blue moon, much different than the others. That the larger moons, the largest moon, which we will mention only in passing, Ganymede, is quite yellow, tawny, but Callisto is blue. It's a dark moon. Callisto is bigger than Mercury. It is not an insignificant world. Callisto's surface is very heavily cratered, probably going back 4 billion years. It would be, to our mind, imperative to land on Callisto and take soil samples. I never said a return voyage or return mission, but to do in situ soil analysis. Why is Callisto so dark when the next moon in is not at all of that tint or that, should I say, suppressed magnitude? The dark areas are likely eroded ice. So what has eroded the ice? Is it the proximity of Jupiter, or is it solar radiation? And if it is solar radiation, why is the effect on Callisto so different from that of Ganymede, the next moon in? It is likely, according to recent estimates, or at least recent hypotheses, that there is a, quote, salty ocean, perhaps 250 kilometers under the surface of Callisto. This is an uncertain proposition, but by putting seismographs on the surface of Callisto, so one can triangulate, it would be possible to investigate the possibility of this deeply, deeply buried salty ocean of unknown depth. The ocean, as proposed, plus the rock core on which it would rest, and I do not know what the current estimate of the diameter of that core would be of rock, could, given a tension zone, be a potential habitat for life in a totally dark environment. Now, this question of life on a strange world like Callisto brings us back to the drive to explore Mars. It's what we have come to call the L word. Now, the L is like this as the viewer sees it, And the L word is a 4-letter word, and it's about life. And we have noticed that selling exploration of Mars, not only to those in politics who must fund the enterprise, but to the general public, always carries a rider about the possibility of finding life on Mars. We do not discount that possibility, but there are possibilities for life on other less hospitable worlds insofar as Mars is hospitable. And one of those places could be Callisto, in addition to the world ocean on Io. There are the peaks of the craters on Callisto are capped with water ice. And there is a very thin atmosphere that is composed of carbon dioxide, hydrogen, and free oxygen. We deem Callisto highly worthy of a lot of study, at least by the United States and by partner nations. Then there is Titan, which belongs to Saturn. It is the only world besides the Earth on which we have clear evidence of liquid formed topography. And by liquid, we do not mean water, not at that distance from the sun. It is an atmosphere of nitrogen, and this atmosphere is so dense that it lends itself to cloud formation, which until the first probe went by Saturn in the 1990s, a pioneer, was impenetrable, except possibly to fine radars. Of that, we know nothing. At least we're not familiar with the experiments that may have been performed with radar. So we have weather, serious weather on Titan. We have rain, we have wind, we have clouds. And this atmosphere produces 50% more than Earth pressure at surface. There is a thick crust on Titan with water ice rather than methane ice. In other words, there is enough water on Titan to be a significant feature of the topography. There is liquid methane plus ethane, which causes landform shaping, and there is considerable rain that falls on the surface of Titan. The raindrops, given the instability of the liquid, can be as much as 9.5 millimeters, which is about 1/3 greater than the raindrops which fall on Earth. Given the inertial mass of these large raindrops, they can have a significant impact on the shaping of landforms on that world. The Europeans have done a magnificent job with their Huygens probe in the last decade, and we should follow up on their excellent work. The empire of the sun, the inner planets. For the purposes of this present discourse at this time, I would like to move directly into Mercury, although Venus exploration and the scholarship that has gone with it is much greater for Venus than it is for Mercury, because the first probe to Mercury did not arrive there until the middle 1970s. But Mercury is a very small world and extremely dense. As Clayton has so well put it, It is almost as if Mercury, which looks like the moon, is the mirror image or the opposite or the upside down of the moon. He put it that the moon is like a big cheese ball by comparison with her density and her size. Mercury is like a bowling ball with a huge core that bespeaks of a planet that has been pummeled and beaten, and much of its crust is gone through billions of years. It is 7 times brighter. I'm sorry, my notes are unclear. It is the hottest and coldest place in the solar system by turns, because Mercury does rotate, as opposed to what was believed when I was a boy learning astronomy. It was thought until the 1960s, the middle 1960s, that Mercury was tidal locked with one face toward the sun. That is not true. We need not visit that discovery. On the day side at noon, it can be 430 degrees Celsius. At midnight or beyond, on the night side, negative 180 degrees Celsius. There is a microscopic atmosphere, barely worthy of its name. To put landers on Mercury would be a worthy enterprise to study this very, very thin atmosphere, and moreover, to plant seismographs to see what the effects would be as Mercury goes around the sun in its rather elliptical orbit. I do not have the data here on how elliptical orbit Mercury has. But the diurnal effects are considerable, and we ask, wouldn't it be great to have landers on Mercury which could be making thermal infrared images of the landscape as it cools with the increasing night in a couple or maybe 3 infrared wave bands to study the stratigraphy or the geology of Mercury by infrared on the surface as opposed to an orbiter, which we also should consider. And to study Mercury is like studying, as Clayton has alluded, the distant brother of the moon, except with a tremendous density as opposed to the moon. The moon is only 1/81st the density of the Earth. I do not know the comparison of Mercury to the Earth. Mercury, furthermore, is deep within the gravity well of the sun and has an elliptical orbit, meaning that the gravitational influence on Mercury from the sun will vary. Moreover, Mercury has been subjected for billions of years to the most brutal electromagnetic radiation and corpuscular radiation. We wonder whether it would be worth, rhetorical question, putting petrographic microscopes on a lander to study the possible creation of unique mineralogy under the dual conditions of the varying solar gravity well, in addition to the influence of the solar weather, broadly defined. It is reasonable to expect, speaking as a non-mineralogist, that there might be some exotic formations or some strange things that may have formed, even if it takes a coring mechanism to get at them. Mercury looks a lot like the moon, to repeat. There is at longitude 90, Mercury's longitude 90, a huge sorry, it's in the northern hemisphere. Well, to repeat, at longitude 90 west, there is a great rift valley, this huge rift valley that covers much of one hemisphere at that longitude. It is not like a great rift valley of Africa. That was caused in Africa by tectonic forces. There were no tectonic forces on Mercury. So what could have formed this great rift? Moreover, there is a huge walled impact plain, reminiscent of the very large walled plains on the moon in the northern hemisphere. How interesting it would be to put a lander in the middle of it and take corings to some reasonable depth based upon what a probe could carry to see what the subsurface is like. There is a lot of so-called geology, excuse the expression, GEO, Earth. There is so much geology that could be done in mineralogy on the surface of Mercury. And to our mind, we need landers. Mercury has been too much ignored. We understand that slowing down probes to Mercury, just because one is going downhill toward the sun, does not make Mercury that much easier to reach and to orbit and land upon. We understand the trajectory difficulties, but Mercury is nonetheless worth knowing. And we have done, until the last, say, decade, or we've done too little for Mercury. He's been ignored, and this should end. We may or may not return to Venus. Neptune is a beautiful world. There is some hint of its beautiful color in an amateur telescope, but the Voyager probe in the 1980s showed us the true marvel of that far-off world, which is at the end of our solar system. It is an ice giant. One author says that calling Neptune a gas giant is not really descriptive of what the planet is like. There's far more to Neptune than a big ball of gas. It is 4 times the diameter of the Earth. We must investigate latitudinally spread out markings. We see it on the slide here, both dark and light, extended along lines of latitude. We must explore the rate of formation and disappearance of these things to understand the atmosphere and possibly the surface of that planet, such as it is. The equatorial winds, working from memory, there is very serious weather on Neptune. Working from memory, I believe 1,200 to 17,000 miles an hour, pardon me, kilometers per hour, equatorial easterly winds. If, we emphasize if, Neptune is a panthalassa, a water world under that dense atmosphere, then the surface of the planet at the equator might be difficult to establish because of titanic waves and a froth, basically a homogenization of atmosphere and surface. And I do not know, and Clayton does not know, certainly, whether there are huge cloud-to-cloud lightning bolts or air to surface to the ocean, or this, given the violence of these winds, that the surface, to repeat, may be difficult to distinguish from the atmosphere itself as a result of this emulsion. we do not know what has been done with radar studies of Neptune, but given the distance and the distance decay of radar, perhaps nothing would come of that, at least beyond an indicative phase of research. And so we propose, we practically insist that we send more than a flyby, an orbiter around Neptune, which is an enterprise that is certainly worthy of the American ingenuity and ability. We have already, with Triton, that huge moon, it is a retrograde satellite. Triton was a capture. Who knows, hundreds of millions, billions of years ago. Triton probably originated outside the formal solar system, or the solar system proper, the commonly understood solar system, out in the Kuiper belt of objects beyond Neptune, the trans-Neptunians. Triton is a capture. It is the only moon that is made mainly of nitrogen ice. It is an extremely bright little world, a 70% albedo. By comparison, the moon is 6 or 7%. Triton is a very bright object, and it probably explains why it was so soon discovered after the planet of Neptune itself. Very few years, because it's bright. Triton is well within the range of an amateur telescope, so long as the moon is properly positioned away from the planet. The core, and this is a question mark of Triton, is of rock and metal. This is the best considered opinion of the day. And it is a world much like, in appearance, much like Pluto, which is coming, which may be a whole species of trans-Neptunian objects, large, with cores that are rock and metal, but have high albedo because of the ice on their surfaces and on the landforms. But the beautiful thing about Triton, to study this proposed new species of objects, is that Triton is much closer than Neptune, easier to study, easier to transmit from, and for all we can tell, at least Clayton and I, easier to land on. And so we should take the opportunity to study Triton carefully to see whether this is a new species of planetary bodies broadly defined. There are sparse crater formations on Triton, indicating a changing surface through the eons. There are landscaping forces going on in Triton because it is a cryo moon with cryovolcanism. These cryovolcanoes were recorded by the Voyager flyby in the 1980s. And it is a high density world with probably a rock core and with seasonal heating due to the summer or winter on Triton, and with the cryovolcanism. Any moon, any planetary body with volcanism deserves a special attention so we can understand the subsurface chemistry and physical forces. The Pluto-Charon system. We insist on calling Pluto-Charon a double planet. We believe that it is a misnomer to call Charon a moon. It is almost an insult to that little world, because the barycenter of the Pluto-Charon system is outside the surface of Pluto. They are going around a common point, and that point is not within the primary planet. For instance, the barycenter of the Earth-Moon system is approximately 1,000 miles below the Earth's surface. We can properly, or at least sensibly, call our moon a satellite. But this is a double planet system, a double world, and going around the barycenter are these tiny little moonlets that have been captured over hundreds of millions or maybe billions of years, sent there and trapped forever. No one is proposing, least of all Clayton and I, that we attempt to land or take a soil sample from any of those baby moons. But we do call on the NASA and the American decision makers to send another expedition like the New Horizons to that system and go in orbit around it. Because the collision forming the micromoons may be visible on one of those two globes. Perhaps the micro worlds were, the micro moons were created by a collision rather than a capture. It would be good to know that, notice these things, and interesting ices, quote unquote, interesting ices by one author, ices of methane and nitrogen, and there are probable tectonic forces on Pluto. What would this tell us if we could go in close orbit on Pluto or even land on the planet? There are nitrogen planes, frozen nitrogen, from convection from below. We should be trying to get temperature readings of that world by, we propose, permanent landers. Now, we do not underestimate the difficulty of landing so far out into the solar system, or actually beyond the formal limits of the solar system, and getting there in a reasonable time. One would have to slow the craft down sufficiently to go into orbit and to eject a lander or two. We are not underestimating the difficulty. That the magnetic field of Pluto is unknown. It is probably zero from Pluto's very slow rotation rate and from the size of the planet. But it would be certainly worth investigating with close flybys any trace or any decently observable magnetic field. And again, this is a double planet. It is the only one in our, that is connected with our solar system. Of course, we do not know, to be fair, what awaits us in the regions beyond in the Kuiper belt. The Little Prince, the creation of Antoine Saint-Exupéry. He wrote it in 1943, the year before he died in action in the Mediterranean. French aviator, poet, essayist, universal man, a genius. He wrote The Little Prince, and I do not know who illustrated that work, the classic work, but the book, The Little Prince, fascinated me, at least when I was in my early teens, because I wanted to go to Ceres and rule, not like a little prince, but like an emperor, and go on mapping expeditions, and I wouldn't have to go to school and bring home my indifferent report cards. It would be a long vacation. Ceres is a main belt quote, asteroid now called a dwarf planet. The Dawn probe did excellent work on Ceres after visiting the asteroid Vesta. The Dawn probe went on into orbit around Ceres and found an amazingly fascinating world, with or without a little prince marching around like Napoleon. One author said, there is abundant water ice in the higher latitudes. Possibly, I think, because in the lower latitudes, Ceres is close enough to the sun for the sun to have some considerable or measurable influence in the equatorial zone. There are active geological features. Active is in they are working. They are producing things. They are sending things out of the surface from below, who knows? It would be wonderful to have a sample return mission sent to Ceres. The escape velocity of Ceres is a tiny fraction of that of the Earth, far less than that of even the moon. The moon has 1/6 gravity of the Earth. Ceres is a small fraction of that. And it would be possible, in our mind, to land a probe there with 2 claws or 3 claws and just fill saddlebags full of Ceres material, blast off and go downhill into some convenient Earth orbit where the containers could be recovered at leisure, rather than attempt a hazardous landing on the Earth. But to bring home material from this loosely consolidated world with an active core, or at least a subsurface, and lots of water, we are entitled to wonder whether there could be some sort of microbial life, or maybe even beyond microbial, on or somewhat below the surface of this icy little world, which is close enough to the sun between Mars and Jupiter to feel the sun's warmth. And we are pleased that NASA sent a probe, the Dawn, to Ceres, and maybe we should encourage other countries to do it too. And now we are at the absolute frontiers of what could be called the solar system. There are a number of large Kuiper belt objects out there with, we are sure, dozens and dozens more to be discovered. We find it unnecessary for this lecture to go into the Oort cloud, this vast sphere of cometary bodies at tremendous distance, going a significant fraction of the distance to the nearest star, which is Rigel Kentaurus, at 4.3, what is it, 4.6 light years from us. But we can call these large Kuiper belt objects planetary bodies because they are large enough to warrant that dignity. And Sedna, to our mind, is the most fascinating. Its formal designation is 90317, which is a tally. It's a census number. So it is the 90,317th, quote, asteroidal or subplanetary body discovered in the solar system. There are a lot of them on record going back to 1801 with Ceres. It was the first so-called asteroid discovered in 1801. And in that 220 some years, there have been well over 90,000 discovered. This trans-Neptunian, as it is also called, or more accurately called, was discovered in 1990. We commend the discoverers for bringing in such a prize. It has a 10-hour, 15-minute rotation rate, and to the best of present knowledge, it does not have a moon, although many of these trans-Neptunians do have moons. The orbit is extremely eccentric. Perihelion, the closest approach to the sun, will occur in 2075 at a whopping 76.4 astronomical units. An astronomical unit is 150 million kilometers, more or less. That's the distance from the sun to the earth. This is 76.5 times farther. If we are to launch a probe to Sedna, we had better get cracking. This little world is very reddish next to the other Kuiper belt objects, or the trans-Neptunians. It is has distinct signature in the longer wavelengths. We wonder why. I'm sure finer minds than ours are wondering why also. Is there internal radiation within Sedna with an effect on the surface of the world? Could it be that Sedna was struck at some distant time in the past, and this is a residue from the colliding body? There is only one way to find out, and that is to go there. Now, Clayton looked into the possibility of a Sedna probe. What he found is, by one source, just a gander, talking point. It would take 30 years to get to Sedna using a New Horizons type craft, the sort that explored so spectacularly Pluto and Charon. That was the fastest object ever launched by man. It would take 30 years to get there at perihelion, which, to repeat, is coming in 2075. The aphelion is so ever much farther than 17.5 astronomical units. As I said at the beginning, if we're going to go to Sedna, we'd better do it soon. The other thing he found is that for a slower craft, possibly heavier, maybe with a better look rather than whisking by Sedna, the proposal would take 100 years to reach Sedna. We believe that such an enterprise would be worth such a long-term horizon, no pun intended. Sedna is worth a close examination, given what we know now in comparison to the other trans-Neptunians. And with that, we duly will take questions insofar as we are qualified to answer them.
Thanks, Gary. I was already told in the chat to tell you how excellent this presentation has been. So that's the first one, not a question, just a comment.
Thank
we
you.
had several questions came up while you were going through various things about Pluto and Charon. And I think the first one, the way I was thinking of it was, I feel like it's the equivalent of the, is a tomato a vegetable or a fruit question. It's the astronomy version of that, which was, you called Pluto a double planet, and someone was like, wait, it's a planet again? So can you explain what you mean by planet, or whether it should be a planet versus asteroids and dwarf planets? And
all right, mea culpa maxima. Yes, I have sinned against the Mother Church and the Vanguard Party, which kind of resembles the Mother Church. All right, I am falling back into the colloquial We'll call it a double world or a double trans-Neptunian. All right, sorry. I'll have to just wash out my mouth with soap. My mother did that a couple of times. Sorry. I rest my case.
I do feel like it is sort of that idea of it can be both thing, right? It depends how you're talking about it. So, yeah, that's,
Oh,
yeah.
wait,
Someone
we are,
else,
go ahead, go ahead.
oh, I was just gonna say, someone else asked, could we get to Pluto in their lifetime, letting you know they're 83? That's what Roger asked. So,
Well, Roger, my mother lasted a lot longer than you are lasting to this point. And it depends on the seriousness of purpose, an expression of which is the willingness to fund it. And I say yes. But then Clayton and I are rather demanding sorts, as you may have detected from this discourse. I mean, we want everything and we want it now. So, well, we're Americans, and no, as Homo sapiens, I know I was born yesterday in saying this. If we weren't so busy cutting one another's throats, we could have probably walked on Mars by now. But don't get me started on that. So the question is, sir, yes, it is possible and should be.
another question came in relatedly from, I think it's from Roger also. If you're picking one of these as a first point, what is your preferred best option? He votes for Enceladus.
Well, la-di-da. Well, spank my fanny. Spank Clayton's too while you're at it. Well, all right. We are open to any reasonable suggestion, and it sounds perfectly reasonable. Just because we decided to ignore Enceladus doesn't mean it should be. I mean, we are immortal, in spite of all our behaviors. Well, so Enceladus sounds wonderful with the geysers. To fly through those geysers and see if we could pick up any interesting minerals, and who knows, maybe little tiny creepy crawlies with undifferentiated DNA, like the cyanophytic bacteria, or if you prefer algae. All right, beyond that, we are out of gas.
Do you have a preferred, if you had to pick one as a starting place for all of the places that you listed, is there one that you would use as the starting part? I know you want them all.
Yes, we got to go to Mercury.
Okay.
All right, we have, that is not the first in this lecture, but to my mind, I have not polled the delegation here on this. That is the top priority. There's so much fascinating business going on Mercury, and it is friendly. Well, I almost said friendly, foreign, and near, like Canada, but let's just say near and foreign. It's not a friendly place, but that would be my first choice. Clayton, what do you say? All right, see? It's unanimous. It's like the Supreme Soviet here. It's unanimous. It's always unanimous. Thank you, Clayton, for backing me up on that. You could have cut my throat if you had chosen, but you didn't. There.
Your friend Mark Christensen popped in and said the New Horizons probe took 9 years and change to get to Pluto. Slowing down to orbit would expand the timeline. I guess and think of how long it would take us to get there. And he also said, of course, if you can use atomic power for the engine instead of chemical, it would change everything.
Well, yeah, but Mark John, I would like to point out years ago, we explored this. I ran it by you because you are, well, along with Clayton, you're my brain trust. That we're talking about an interstellar probe, and you pointed out, I never considered it, that materials science to contain the exhaust vessel, to contain the reaction we don't have the materials yet that can do that for interstellar. And I kind of wonder about all the way to Pluto, because it would be a longer mission than New Horizons. And you can send me a hate-filled email when I get home.
We also just had a comment from Ed Pank from the Royal Oak Library. He said, it was excellent, and he hopes to see more of you on this platform. Many other people said similar things.
Oh yes, Ed, my astronomy buddy from the Royal Oak Library. Yes, I never paid you back that money and I left town.
Oh, he laughed at that. And then when you said Mercury, I'm going to say it, Vanessa said Mercury versus Mars. But you're done with Mars, aren't you?
Well, you know, as President Bush the first said, read my lips. We as Homo sapiens must not be done with Mars. I mean, that's a grand enterprise, Mars. I'm just saying the United States should focus her attention elsewhere, that we have done enough. That's the editorial comment on which this whole diatribe is based. There's nothing wrong with Mars, but there are other items of business out there in the solar system. There, take that.
That was the last of the questions that I saw. If anybody else has other questions, they can put them in there. I liked your idea about Triton and Neptune. I would love to see us get out to Neptune myself. So I think the idea of doing Triton at the same time seems.
Well, you see, Ed, as you know, I am the Grand Duke of urban astronomers. I used to be, but I resigned my commission. And I found Neptune on a Saturday night from my mother's house, 2 kilometers north of downtown. And I've always had a fascination with that world, especially when I did a little reading about it, Ed, that to think of a panthalassa with 1,500 kilometer per hour equatorial winds, this is a vision out of hell. But does it have to be a dark world, or are there lightning strikes? And I remember I gave a talk about this at Cranbrook and ended it with a rousing, we must mount an expedition immediately. Well, I wanted to go there, but I'm getting a little old. So
Yeah.
Neptune, you know, Neptune is not just some cold blob with a, you know, with a hidden ice cap. There could be an ocean over much of that world, maybe even all of it.
Yeah.
I
Well,
miss
thank
you,
you.
Ed.
Did
Ed.
you want to open it up to people using
Oh
their
yeah,
mics?
well, you and Clayton hold the whip hand. We do what you want to do, right?
Well, if you would like to ask a question yourself rather than in chat, if you raise your hand, go down to reactions under the screen and raise hand. And we can let you
What are we doing?
use your mic.
No, she's talking about raising of hands for questions. Oh, asking them. All right. Yeah, all right. So come on, ask us anything. You know, that we are
That's a
perfectly,
challenge.
we're capable of lying, but it'll sound extremely plausible. We're that good. It's like Professor Harold Hill in the Music Man. That
I
band really.
remember vividly the night that we had the telescope out by the Wilder Library.
Yeah.
And the man came who told us about how the moon landings were faked.
I wrote about that in a posting to the Grand Rapids Association website. It was part of my Astronomy in the Big City series, which is, most of it is self-aggrandization, of course. But I put that in. I said, this jackass went on forever and ever, and Jennifer is like Mother Teresa dealing with this dude who just banged on, and the buses are going by, and it's on 7 Mile Road, and he wouldn't shut up. And I'm just a guest, and I felt for you, Jennifer. I really did. You were a princess amongst women dealing with that idiot. Wow, boy, I feel better now, man.
Well, I guess the questions and comments have been passed on. Thank you so much,
All right.
Gary and Clayton.
No, we thank you. We
It's a lot of
thank
good food for thought. So
Yeah,
I'm going to be
yes.
thinking about this for a while
we
now.
thank the Detroit Public Library System. We thank the Wayne State Planetarium, and Megan knows about my buddy Mark John out there in Illinois.
Mhm.
They have had good business together. So Clayton and I thank both institutions, in particular the creme de la creme in your excellent personages. And the guests, and further the deponents say it not.
Well, thank you so much. We've had requests to bring you back, so we'll have to talk about a topic.
Yeah. It's
Your
good to
bad
hear from
luck.
you, Gary.
Goodbye.
Okay, goodbye. Thank
Bye.
you, everyone, for coming.
Thanks,
Oh,
Clayton.
I forgot. I usually say that I try to have the astronomy programs on the 4th Tuesday. We will not be meeting in
Okay.
July, but in August on I think it's the 29th, we will have Bob Tremblay. He's going to talk about exoplanets. And if you've heard one of his previous presentations, you know he'll be both entertaining and informative in a different style than Gary. This program should be on our YouTube channel. We have a special channel just for the astronomy programs. It should be in about 2 weeks. And if you want to be, it's more difficult to subscribe on Eventbrite than it used to be. But if you'd like to get an email with upcoming programs, you can just email me. I do maintain an email list of that. So thank you, everyone, for attending.
Thanks, Jennifer.
Thank you, Megan. I always appreciate your help.
Sure.
Thank you, Gary and Clayton.
Bye, everyone.
Bye.